We all know a house is only as strong as its foundation. But what about the ground beneath that foundation? That's where ground improvement comes in. It's like making sure the ground itself is strong enough to support whatever you're building. Think of it like this. You wouldn't build a house on a swamp, would you? The ground is too soft, too unstable. Ground improvement is all about turning that swamp into solid ground, something you can rely on. Whether it's a house, a skyscraper, or a bridge, every structure needs a solid base. Ground improvement ensures that base is strong enough to handle the load and stand the test of time. Without it, buildings can settle, crack, or even collapse. That's why ground improvement is crucial for safe and successful construction projects.
Not all ground is created equal. Just like you wouldn't use the same tools for every job, you wouldn't use the same ground improvement technique for every soil type. Some soils, like solid bedrock, are naturally strong and stable. They're like the rock stars of the construction world, ready to build on with minimal fuss. Others, like loose sand or clay, are weaker and more prone to shifting or compressing. They're the ones that need a little extra help to make them construction ready. Understanding the type of soil you're dealing with is the first step in ground improvement. It's like getting a soil test before you plant a garden. This helps engineers choose the best methods to make the ground strong and stable for construction.
So, you've got your soil report, and it's not good news. The ground is weak, unstable, or just plain unsuitable for building. Don't despair. You've got options. One option is to simply walk away. If the ground is too problematic, it might be best to find a different site, but that's not always feasible or desirable. Another option is to excavate the bad soil and replace it with good soil. This is like starting with a clean slate, but can be expensive and time-consuming. You could also redesign your project to work with the existing soil conditions. This might involve changing the foundation type or the building's footprint. The final, and often most practical option, is to modify the existing soil to improve its properties. That's where ground improvement techniques come in.
Ground improvement is all about engineering the ground to meet the demands of construction. It's like giving the ground a helping hand to make it stronger, denser, and more stable. There are many different ways to achieve this, but most ground improvement methods fall into three main categories. This involves changing the existing soil's properties without adding anything new. Think of it like rearranging the furniture in a room to make better use of the space. Examples include compaction, which squeezes the soil together to make it denser, and drainage, which removes excess water to improve stability. This involves mixing the existing soil with other materials to improve its properties. It's like adding flour to thicken a sauce. Examples include adding cement or lime to the soil to increase its strength and stiffness. This involves inserting reinforcing elements into the soil to create a composite material with improved properties. It's like adding rebar to concrete to make it stronger. Examples include installing geotextiles or steel grids to reinforce the soil and prevent movement.
Section 5. Building a stronger foundation. The goals of ground improvement. The ultimate goal of ground improvement is to create a foundation that can support the weight of a structure without excessive settlement or movement. But there are many specific ways ground improvement achieves this. One key goal is to reduce the soil's compressibility. This means making the soil less likely to compress or settle under the weight of a building. Imagine squeezing a sponge. That's compressibility. Ground improvement techniques aim to make the soil more like a brick, less likely to change shape under pressure. Another goal is to increase the soil's strength. This means making the soil better able to resist deformation or failure under stress. Think of it as increasing the soil's ability to carry a load without collapsing. Ground improvement can also improve the soil's load-bearing capacity, reduce permeability, and control vibrations. It's all about creating a stable and predictable foundation for your construction project.
Section 6. Timing is everything when to improve your ground. Ground improvement isn't something you just do on a whim. The timing of these techniques is crucial and depends on the specific project needs. Pre-construction ground improvement takes place, you guessed it, before construction begins. It's like prepping the canvas before you paint. This is the most common scenario and allows engineers to address any ground issues before they become problems. Sometimes, ground improvement is necessary during the construction process itself. This is known as on-construction ground improvement and is often used to address unexpected ground conditions or provide temporary support during excavation. Finally, post-construction ground improvement is used to remediate existing foundation problems or strengthen the ground beneath an existing structure. This is like fixing a leaky faucet. It's better to address the issue sooner rather than later.
Section 7. Ground Improvement Techniques. A closer look. Let's get down to the nitty-gritty and explore some common ground improvement techniques. Soil densification. This technique involves compacting the soil to increase its density and strength. Imagine using a steamroller to flatten a dirt road. That's soil densification in action. It's often used for loose sands and gravels. Drainage and filtering. This involves removing excess water from the soil or controlling its flow to improve stability. Think of it like installing a drainage system in your yard to prevent flooding. It's commonly used for waterlogged soils and areas with high groundwater tables. Admixture stabilization. This involves mixing the soil with stabilizing agents like cement, lime, or fly ash to improve its strength and stiffness. It's like adding flour to thicken a sauce. These admixtures bind the soil particles together. It's often used for clays and silts. Soil reinforcement. This technique involves incorporating reinforcing elements into the soil to create a composite material with enhanced properties. Imagine reinforcing a wall with steel beams. That's the basic idea behind soil reinforcement. Common reinforcing elements include geotextiles, geogrids, and micropiles. Grouting. This technique involves injecting grout, a specialized mixture of cement, sand, water, and other additives, into the soil to fill voids, bind loose particles, and improve strength. Think of it like filling cracks in a wall with sealant. It's often used for fractured rock and soils with large voids.
Section 8. Choosing the right tool for the job. Factors to consider. With so many ground improvement techniques available, choosing the right one for your project can feel overwhelming. It's like trying to pick the right tool from a well-stocked toolbox. Several factors influence this decision, including soil type and properties. Different techniques are suited to different soil types. You wouldn't use the same method for loose sand as you would for stiff clay. Project requirements. The type of structure, its load-bearing needs, and the desired performance characteristics all play a role in selecting the appropriate technique. Building a skyscraper requires different ground improvement than a single-family home. Site conditions, factors like groundwater levels, accessibility, and environmental considerations can also influence the choice of method. Cost and time constraints. Some techniques are more expensive than others, and some take longer to implement. Balancing budget and schedule with project needs is crucial. Environmental impact. Some ground improvement methods have a larger environmental footprint than others. Choosing sustainable and environmentally friendly options is increasingly important.
Section 9. Ground improvement, your foundation for success. Remember, a strong and stable foundation is the cornerstone of any successful construction project. Ground improvement techniques provide the tools and techniques to transform even the most challenging ground conditions into a solid base for building. By understanding the different soil types, the various ground improvement methods, and the factors influencing their selection, you can ensure your construction projects stand on solid ground for years to come. So, before you build, make sure you've got the right foundation in place. It's an investment that will pay off for generations to come.